Hello, welcome to my space station. Have you ever wondered how we humans on Earth are able to communicate with faraway space probes like the Voyager 1, Voyager 2, the New Horizons, and Juno? Well, we use a system called the Deep Space Network, and we'll get into that in a second. First, let's understand how we communicate with space probes in general. Now, take the James Webb Space Telescope. It is not that far away from Earth. It sits at the point at the Lagrange point 2. Now, what are Lagrange points? Well, when you have two bodies, like two large bodies, like take Earth, right? And let's take something else like planet A and planet B. Now, planet A will exert a gravitational force on planet B and vice versa. Now, there are different formulas that describe this, and I will cover one of them especially in a different video. But basically, it says that the gravitational force that, like, where the point will cancel out is basically the gravitational constant multiplied by the mass of the first object, the mass of the second object, divided by the total distance between these two squared. The distance is squared, not everything. So, this is the formula we use, and to determine at what point will the gravitational forces of these two objects be like negligible. So that's what the Lagrange points are. They go from 1 to 4, and the first Lagrange point is where the gravity of the Earth and the Sun cancel out towards the middle. That's basically where if you place a space probe in the middle of that, like at Lagrange point 1, the probe won't need much like thruster input to keep itself in position. It will just naturally be in a perfect orbit because neither the Earth nor the Sun can input like a large gravitational force on it. Lagrange point 2 is on literally the completely opposite side, and that is where the gravity of the Sun can no longer influence it, but the gravity of Earth influences it just enough that it doesn't fall towards it, but it's in a stable orbit around the Sun. That is where the James Webb Space Telescope is placed. Now, communications with the James Webb Space Telescope is considerably easier than communicating with things like Voyager 1. See, the thing is, the time when Voyager 1 and Voyager 2 were built, the the computers of that age were not as advanced as we have now. The memory inside Voyager 2's internal systems is just a few hundred MB. That's it. That is a lot less. And back in that time, that was actually a lot. Like take like when NASA now has to give instructions to Voyager 1, they have to call on specific people that can write code in assembly language and Fortran, the two languages that Voyager 1 was built in, and they have to be very mindful about how they use the variables, how they use the space, because Voyager 1 is running out of space. James Webb Space Telescope has nothing like that. It has loads of memory and it has loads of potential to expand its memory by clearing up old ones, right? So how would one of the, let's take the Deep Space Network, communicate with the James Webb Space Telescope? Well, it will send out some specific assigned frequency which the satellite dish on the James Webb Space Telescope is designed to recognize. Through that, we'll send bit by bit, like in a very fast fashion. We would send it bit by bit, and this dish on the James Webb Space Telescope would actually pick up those bits, put them together into a byte, and like do the necessary instructions that we have programmed it to do, and then they would execute whatever we have told it to. For example, we want it to fire its thrusters, move like take 3 degrees to the right, and take a picture. We'll send that instruction, it's going to execute it, and it's going to give us the output. This is done in a matter of a few minutes because it's not that far away from Earth. Now take Voyager 1. Communication with it is a few hours, like around 10 to 20 hours per message, right? Depending on the length of the message. And since the memory is also low, it takes a lot of time for people to specifically create the code which does not like exceed the memory capabilities of the Voyager 1. And so it takes a lot of time. It takes 20 hours for just one message to go from Earth to there. And because it's so far, the bits that we send, the radio frequency that we send, will eventually decay over time to the point where maybe the systems on the space probe won't be able to recognize it. Now that is where the deep space network comes into play. A normal satellite dish will not be able to communicate with Voyager 1 and Voyager 2 and the things like the New Horizons, the Parker Solar Probe, that effectively as a deep space network would. Why? Well, the deep space network is engineered in a way that allows it to basically turn the entirety of Earth into one huge satellite dish. Basically, there are three satellite dishes, one in Arizona in the US, one in Spain, and one in Australia. These are very strategic positions because they're around 120-degree angle from each other, if you can look on the globe. And basically, what this means is that at all times, at least one satellite dish is pointing towards outer space. That means that we can communicate with one at all times. And the positions are also so strategic that basically, if let's say we want to send a message to Voyager 1, we can coordinate like since the Earth also rotates, right? We have to wait for a perfect time where all the dishes are in a perfect position that basically any signal sent will be picked up by all of them. And them, like all the three of the satellites, let's say we want to send a message. Now, the message has to be very strong. We have to use very strong frequencies that if it decays over time, it will still be interpretable by the satellite dish of Voyager 1. Like it could still pick it up. So that's why we merge all the signals into one, like send them in the space, same frequency, we merge them, and then we beam it into outer space. So that is how the deep space network essentially communicates with faraway objects. Now, what exactly does it communicate with? Obviously, Voyager 1, Voyager 2, the Parker Solar Probe also, the New Horizons spacecraft, Juno, which is orbiting Jupiter. These are the main things that it communicates with. Also, sometimes it is also called upon to communicate with, take the James Webb Space Telescope, some Earth, some like satellites orbiting Earth at a high altitude. Usually, this is pretty rare because these other things have their own dedicated systems, but sometimes it is needed. For example, if whenever Parker Solar Probe approaches the sun, it is too far away for any normal antennas to pick it up, like to send proper frequencies to it. So that is why we often call upon the deep space network to communicate with it. But when the Parker Solar Probe, like it's on an elliptical orbit around the sun, right? As soon as it's towards the end of that orbit, it's like very close to Earth. That's when normal antennas can also be used to communicate with that. So why is the deep space network so essential? First of all, it helps us communicate with the faraway like spacecraft that we have put, and it also serves as a reminder that human beings can always like communicate with their like how can I explain this, with their creations that they have sent on for outer space. So basically, one of the biggest techniques that the deep space network uses is compression. Basically, when you send out a signal, the like the technology that they use tries to compress the signal as much as possible into the tightest space to ensure that the like it can be as strong as possible. Because see, if you send out like take a flashlight, when you have the flashlight at the largest spread, it will give out less light than if you focus it at one point. That is basically what the satellite antennas try to accomplish when they like work all together. They try to focus it at one point. Now, how do you do that? Well, you have to know the position of Voyager 1 and like whatever probe you're trying to send it to. And that is where the issue comes with the telemetry data. Basically, since it takes so long for us to communicate with the faraway probes, it is possible that if, let's say, right now, Voyager 1's nuclear reactor just goes silent, there's no power, it can't receive data, it can't send data. We don't know where it is because it's been more than 24 hours since we last communicated with it. And it could have easily moved, it's moving around 17 kilometers per second, which is a very fast speed. It could have easily shifted a lot in our night sky, and it would be harder to communicate with it anyway since it can't pick up the communications. This is one issue with the few place an object very far away. And the deep space network tries to compromise that by basically trying to make the signal as narrow as possible, as strong as possible. So I hope you learned a lot about how we communicate with our probes in outer space, which are very far away. And I'll see you next time. Bye bye.